Hey, Algebra 1, we're trying to deal with a couple of things here. What's the difference between 3 times x and x to the third? Well, we have a lot of different concepts going on here. So remember, 3 times x is not the same thing as x times x times x, right? That exponent means we have repeated what's going on. So we're trying to get to our first rule today, which is the product rule. And you can see the first one's written out. 2 squared means 2 of them. 2 to the third means 3 of them. So when I look at it all together, I have 5 of them. Right? So if I have 3 to the fourth, that's 3 times 3 times 3 times 3. And 3 to the fifth, 1, 2, 3, 4, 5. But altogether, I have 3 to the ninth power because there's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we want to do is we want to try and come up with a rule so I don't have to do this over and over and over again. So 11, 2, 3, 4, 5, 6. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. Wait, I feel like 11, and then what do you have? 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. You know, I keep adding these numbers together. So how about I just add those exponents together because I have the same base, right? Anytime I have the same base, I can just add those exponents together. So if I try that idea here, I get 1, 5, right? 4, 1, 3, 4, 5, 6, 7, 8. So would that be 5 to the 8th power? 5, 1, 2, 3, 4, 1, 2, 3. Well, yeah, that's to the 8th. All right, so if I have 9 and 7, x to the 9th, x to the 7th, that should be x to the 16th. Right, so what's my general rule, right? So that's what we're really after. So I have x to the 9th times x to the 7th. I have the same base. That means I should just add my exponents. X to the 16th, we just had that one. All right, so why do you think this is called the product rule? That's our first question. Product rule, right? We're adding. So why is it the product rule? Remember, we're multiplying the bases, which causes us to do the addition. So it's somewhere along those lines. All right, so what you can do right here is make up your own example and fill it in, right? It's as simple as saying 3 to some power times 3 to some other power should be 3 to some power. So pick some numbers and make that rule work. All right, distributive rule. All right, so you kind of read through what's going on here. 2 times 3 to the third. So 2 times 3 times 2 times 3 times 2 times 3. But it means I have 3 of those 2's and 3 of those 3's. Right? So I don't want to spend too much time writing all this stuff out over and over and over again. I just want to try and make a concept of, all right, so that means I should have 4 4's, 2, 3, 4. So that's 4 to the fourth. And I should also have 6 4's, 2, 3, I'm sorry, 4 6's, 6 to the fourth. Okay. So that seems pretty straightforward in what we're doing here. So I'm going to make sure that this one, right, I have 2 of each of these. So 3 squared, 4 squared, 5 squared. The last one's a little bit tricky, right? So I should have 3 6 times and x 6 times. So 3 to the 6th, x to the 6th. So even if it's a numerical and a variable, I want to make sure that happens. All right, so we're going to come up with our rule in words, determine a general rule. What happens? 2 different things, both raised to the same power. Okay, so how would you state this? Okay, and why do you think it's called distributive property? Remember distributive property? Right, so if we had 3x plus 5, right, we would distribute that. So very similar to what we're doing. Okay, we didn't study anything yesterday, so I think that's okay. And then we would come up with a rule. And I would encourage you to use something like 5 with an x and maybe a y as well, and then take that to some power. So it become 5 to what power, x to what power, and y to what power. So that's distributive. Quotient. Quotient, remember, has to do with having to divide something. So let's take a look at the first one here. We got 2 to the third, 2 squared. So I have 3 of them on top, 2 of them on the bottom, but notice what happens is I'm able to divide those out. So I have just 1 left, And that one is on the top. It's positive, right? So when I do this rule, I want to make sure they all stay on the top unless they come out to be negative, right? So that means I would have 7 3s on top and 4 on the bottom. Well, I would definitely have some left over, right? I know the difference is 3 and 7 is more, and that's on top. So I need 3 to the third. And I'm not going to write all this out because I don't want you to, right? This is the idea is we're trying to get through these rules. And so if I had 10 x's on the top and 4 on the bottom, I could cancel out 4 of them if that turned into a 6, right? 10 minus 4 is going to give me that 6. So we want x to the 6th power. All right. So what about 5 to the 12th divided by 5 to the 7th? So it doesn't matter if it's a number as the base. 12 minus 7 is still 5. Right? So we have 2 ways to think about it. The rule is to subtract, or we can go back and say, well, I have 12 on the top and 7 on the bottom, so I have 5 more on the top, which is still subtraction. We just kind of think about what's going on. Why? Right, we get 20 minus 8. Well, that's 12. Right, so come up with a problem. What would end up being a to the 7th, b to the 3rd? Right? So I need to find out a to some power, b to some power, over a to some power, b to some power. And I want to make sure they subtract. So I might use something like a to the 10th over a to the 3rd. And I just need the difference to be 3. Okay, your turn. All right, let's fill these in and see what you can do with it. And general rule, what's happening here? All right, if I gave you x to the nth power, x to the mth power, I just like to exaggerate that. That'd be n minus m. Okay, and then we're going to come up with an algebraic one. So plug some numbers back in here and rewrite that. The 0 exponent rule. Oh my goodness, you guys know what's going on here. 2 to the 3rd divided by 2 to the 3rd. Well, my rule is to subtract, so I would get 2 to the 0. Anything to the 0 power is what? 1. All right, 5 to the 0 is 1. X to the 0 is 1. Anything to the 0 should be 1. Okay, so this division gives me that rule. All right, so anything in the 0 power, that's going to be a big old 1 right there. All right, now that distributive idea is going to work for all these fractions. So I want to make sure this goes to the top and the bottom, because 2/3 of the 4th power simply means that I have 4 2s and 4 3s. All the 2s are on top, all the 3s are in the bottom. Okay, so this would be 1 2 3 4 5 6. Okay, this would be 3 to the 6th over 5 to the 6th. It started off as 3/5 to the 6th power. Okay, so we can kind of script these in. I don't need to see the middle. We don't need to write that 100 times. 8 over 2, we want that to be to the 6th power as well. This is 2, careful, to the 3rd, x to the 3rd over 9 to the 3rd. Why did I say be careful, right? We have this distributive idea that it's going to go to each factor in there, the 2, the x, and the 9. All right. So if we have a to the nth and b to the nth, right? This would be a great one to put down here as an example of what's going to happen. We're going to distribute that even though we're dealing with a fraction, right? And put those in there. So we have a couple ideas. Distributive rule for quotients, right? So I'm going to distribute to the top and the bottom of those fractions, a over b. And I like what we had in that last one, right? Even if I put a 5 in here, and we want to do that to the 3rd power. 5 to the 3rd, a to the 3rd, b to the 3rd. Okay, so down here, you can come up with your own to show that you know what we're talking about. Oh, it scrolled really fast. All right, here we go. I think this is one of the last ones. And we're getting close. Negative exponents. We already talked about that. Here we go. I'll try and wrap this up for you. All right, so 2 squared, 2 squared, 2 squared. Why do I have 3 of those? Because it was 2 squared to the 3rd power. Well, that means I have 2 to the 1st, 2 to the 2nd, 2 to the 3rd. That's 6. So what do I see? I see multiple exponents. So what I'm going to do, 2 plus 3 would give me 5, but this one has to be 6. So it must be multiplied, right? All right, so I'm not going to write this stuff out, right? That would be a whole lot of fives. Right? How many exactly? That's what we're after. So if my rule is when I see two exponents, I'm going to multiply them. So this should be to the 12th power. Okay, so how can I get 7 to the 12th power? That might be 7, I don't know, to the 2nd power. What else would have to go with that? 2 times what gives me 12? Yeah, that's going to be 6, right? So it'd be 7 squared, 7 squared, 7 squared, 7 squared, 6 times until we deal with that. We can work a little bit backwards here. X to the 6th power. Pen doesn't want to work all of a sudden. 1, 2, 3, 4. I need 4 of those. I'm certainly not writing this out here. You can if you want to. So that should be x to the 6 times 4 is 24, right? So if you fill it in this box right here, make sure there's 24 x's, okay? All right. And I also want to distribute that like we have been doing. All right. So this is going to be 3 to the 15th. This would be y to the 6th. All right. I need 20 times 32. I'm never going to write that out. That's crazy. Okay. So let's do this. This would be a 64, 640. So if you're going to fill that in, write really small. Okay. That would be hilarious. All right, so we got power to a power. I love this example squeezed right in here. Kind of goes along with when we were distributing to our quotients, right? Our fractions. So we have a couple of those. So what happens is we're going to, again, distribute. Okay. We're going to use the power rule. We have to distribute it to everything in there. And if it were a fraction, we would do that as well. All right, how is this rule different from the product rule? Okay. So this is talking about n maybe squared, so it becomes x to the 2n, right? I'm multiplying those exponents. All right, and I would encourage you to use something with an extra number in front, right? 5x to the 3rd, and maybe use that to the 4th power and see what happens. All right, last one is our negative exponents. You guys know exactly what's going on here. So my rule by division, right? My quotient is to subtract. So I don't really like the way this is scripted here, but let's take a look at it. If I subtract, I get 2 to the negative 3rd. What that means is I should have this answer right here. Right? I like this answer, right, as a final answer. What's really happening at 2 x's on top, so 1, 2, they cancel. I need something to hold its place up top, and that's a 1, so 1 over 2 to the 3rd. So I can see here that if I have 9 a's in the bottom, there are 5 extra ones on the bottom. So I'm just going to put a 1 on top to hold its place. Right, so up here we had x to the 3rd with a y, and down here I have x to the 3, 4, 5, 6, 7. Right, so my final answer becomes y over x to the 3rd. So we can deal with those a little bit. So these really become in their own little problems as we work with them. So with my a's, I end up with a to the 5th on the bottom. And with my b's, 5 minus 12 becomes negative 7. So I'm going to make it positive 7 on the bottom, right? Because in our work, we're always going to write things with a positive exponent. Okay. I get a little problem though, because these don't really turn into anything. But what's anything to the 0 power? Well, that's 1. So I get 1 over 25 to the 4th. And that could work. That could work. Right? What does a negative exponent mean? And we've been through that, right? X to the negative 2nd means it's 1 over x squared, because our original problem was over 1. Our positive expressions with negative exponents negative. Oh no, because it's a positive expression, right? Remember, negative exponents just have to do with taking reciprocals. And then we got our last one here. All right, good job with that. And we'll continue working on these one by one, and then they start to get mixed together. So make sure you have good command of each part.